This is our last section in Chapter 3 with inequalities, and arguably the most complicated. Hopefully, I can explain it well enough that you understand how to set these up. This happens more often than not. More often than not, you don't just say, I could, if you're talking about a real world situation, I could sell more than 32 pizzas and make a profit, because you wouldn't, feasibly, you wouldn't sell 500 billion pizzas. That's not just it's just not a feasible answer. And so we usually look at a range of numbers between this and this. So the age of the students in this class are between 11 and 13 inclusive. That's probably true. Write the compound inequality to show the ages of the students in the class. You're going to graph the solutions. I'm going to go through this problem with you. This is how your problems are going to look. It's still inequalities, because it's somewhere in between 11 and 13. Could be 11 in 1 month. Could be 12 in 4 months. Could be 12 in 4 months and 6 days and 5 hours. And I mean, you've got a whole range of ages in the classroom. Nobody's exactly the same age unless they were born at exactly the same time on exactly the same day, exactly the same year. And so we've got a range in there somewhere. And the way we write that is we'll say that the students, I'm going to go with S, but you could certainly go with X or V or whatever. The students are somewhere in between 11 and 13. So S is in between. We have a pretty good idea generally of what in between means. It's somewhere in between the two, 11 and 13. The way we show that mathematically is we say that S is bigger than 11. S is greater than 11, but S is not greater than 13. S is going to be less than 13. So when we talk about betweenness, we're really looking at being greater than one and less than another. This word inclusive, if you think about an inclusive club, you're including people. Everybody is included in an inclusive club. Everybody's a winner. An exclusive club would be one where you maybe have tryouts. And you say, you know what, we're not going to include everybody. This is going to be exclusive. Only certain people can be a part of this club. And whether you agree with that or not, that's what inclusive and exclusive means. So when we see those words, inclusive means you're including everything. Exclusive means you are not including everything. In this case, we're going to include 11. So S is not just greater than 11. S could include 11. So it could be exactly 11 years old and be in the class. Same thing with 13. We're going to include 13. So they could be less than 13, or they could be exactly 13. So less than or equal to 13, greater than or equal to 11 is the way we would write this inequality. Graph the solution. So graphing an inequality like that, we're going to need to have both of these numbers on the graph. Now, luckily, these are pretty close together. So we need to have 11. We need to have 13. 12 is in there. And then I am going to ask you to put at least one number on either side. In this case, we've got 5 numbers, which is what I've been asking you to do. Some of them you'll have more, some of them you can have less. But we need to have at least 5 numbers. We need to have at least one number on either side of our two solutions. So if S is in between these two, S could be anywhere from here all the way to there. And we're going to include 13, and we're going to include 11. So any age right there, they might be in the class, they might be in the class, they might be in the class, they might be in the class. Not over here, though. Can't be 10 in the class, sorry. And that's how these inequalities are set up. So we've got this. This is basically what we just went over. If x is greater than 2 and x is less than 6, we would say that x is in between 2 and 6. It's greater than 2 and it's less than 6. And we have that graph here. You'll notice that's exclusive. We are not including 2 and 6. X is greater than or equal to 2, and x is greater than or equal to 6. X is somewhere in between 2 and 6, and we're including them. We're going to look at some or ones, too. You might say that, well, it could be this or it could be that. X could be less than 2, or x could be greater than 6. And that's how that graph would look. X is less than 2, or x is greater than 6. There's no number that's both greater than or less than 2 and greater than 6. No number exists that's less than 2 and greater than 6 at the same time. It just doesn't happen. So it's got to be one or the other. And that's why those arrows go in opposite directions. Same thing with the last one. x is less than or equal to 2, or x is greater than or equal to 6. Can't be both, and we're including them. So we've got opposite directions. I don't know why I'm doing the pop sound, but it works. What I'd like you to do is I'd like you to try this one. Think back to what I just did a minute ago with the age of the students in the class between 11 and 13. And think about if we have a pH level, that's like the acidity. You know what, I take that back. I'm going to do this one with you. So the pH level is the acidity. It's how much it burns your scalp, basically, of a popular shampoo is between 6 and 6.5 inclusive. So the shampoo, I don't know, we'll go with X. Why not? X is between 6 and 6.5. So it's going to be greater than 6 and less than 6.5. Inclusive, so I'm going to include 6 and 6.5. So write a compound inequality to show the pH levels. All the pH levels for this popular shampoo are between 6 and 6.5, and I'm going to graph it. So I need to have 6 on my graph. I need to have 6.5, so I'm going to go by 0.1. 6.1, 2, 3, 4, 5. I got to have 1 on either side. So 5.9, 6, 6.1, 6.2, 6.3. It's getting tiny. 6.4, 6.5, and 6.6. Itty bitty letters, or numbers, excuse me. Now I'm going to graph it, so I know that x is somewhere in between 6 and 6.5. Could be 6 exactly, could be 6.5 exactly, or somewhere in between. And it would be able to go out into production at that point. And that's how we can set up very festive colors too. That's how we can set up these inequalities. Try this one. Free chlorine. See if you can get this one to work out. I'm assuming you paused it. I'm assuming you tried it on your own. If you did it correctly and you set up the inequality and graphed it, you should have an inequality a lot like this. So if you didn't get that inequality, watch the linked video. Solving a compound inequality. Now we're not just setting one up, we're solving one that's already been created. So -5 is less than x plus 1, which is less than 2. Now, to solve this inequality, I really need to think about it as two different things. We have an inequality here. -5 is less than x plus 1. I can solve that, get x by itself, -1 from both sides. -6 is less than x. Not too bad. Now I look at the other one. X plus 1 is less than 2. Solve that. Well, the same idea. If it's x plus 1 to get x by itself, I minus 1 from both sides. I end up that x is less than 1. So my final answer, -6 is less than x, which is less than 1. So any number in between -6 and 1 could be a solution. So like 0. 0 is in between -6 and 1. So if I plug 0 back into this inequality here, 0 plus 1 is 1. And 1 is less than 2 and greater than -6. So, or excuse me, -5. So really, any number that you pick that's between -6 and 1 will work in that original inequality. And that's what we're trying to find, is what values of x will work in that original inequality there. I just picked 0 as a start because why not? And so that's how we can solve these compound inequalities. And then, of course, we're going to graph it. So -6, 5, 4, 3, 2, 1, 2. So I've got 0, 1, 2. There we go, a little bit longer. So 2, 1, 0, 1, 5, and -7. So I've got more than 5 numbers on there, but I got to get -6 on the graph. I got to get 1 on the graph, and I need to have 1 on either side. I'm going to graph it then. So -6, now you notice we're not including -6. So we have an open circle. We're not including 1, so an open circle, but anything in between would be a possible solution. So you solve the compound inequalities. You basically do the exact same thing, -1, to everything. You do it to the -5, you do it to the 2. And that's how we can get our solution from there. Try these two. Make sure you graph it as well. I'm assuming you paused it, assuming you tried it on your own. If you're stuck, make sure you're asking for help or writing in the text box. I was stuck on this one, -9 less than x minus 10 less than -5. You have the less than symbols on your keyboard. The correct answer for the first one, 1 is less than x is less than 5. Correct answer for the second one is somewhere. Come on, where is it? There it is. -3 is less than or equal to n is less than 2. And we got the graphs there. So double check your graphs, double check your inequality. If you didn't get either of those correct, make sure you watch the linked video. We do one more with you, and then we gotta move on. The last one here that I'll do with these inequalities, or the and ones. So if it's 8 less than 3x minus 1 is less than or equal to 11, I'm going to add 1, so I get 8x all by itself. I do it to all three sides in this case. So we get 9 less than 3x less than or equal to 12. And then to get x by itself, I divide everything by 3. And 3 is less than x is less than or equal to 4. Now, if this was a -3, you would still have to flip things around. So you would end up with, and it isn't, so you don't have to change anything. It'd be -3 is greater than x is greater than or equal to -4. You'd still have to flip everything around if it was a negative. But it's not, so we don't have to worry about that. There we go. And that would be our solution. Oh, graph it, sorry. So graph 3 and 4, so 2, 3, 4, 5, that's not so bad. And we are not including 3, but we are including 4. So we're kind of inclusive. We will accept some people, but not others. Or you do not have this in your notes. I realize that. Please do write this way. You don't have to write the words, solve the inequality and graph the solutions. Just write what's in the blue circle here, the blue oval, the blue blob. Write that down. You got some space. You can write that down. We're going to solve an OR problem. When you're solving an OR problem, again, it's just like solving two different inequalities. You've got this one, so minus 8 minus 8. T is greater than or equal to -1. Or this one, minus 8 minus 8. T is less than -6. So we've got this or that. We're going to graph it. So we got -2, -1, 0, 1, 2, 3. Oops, sorry, missed it. So we've got -7, -6, -5, -4, -3, -2, -1, 0. Got to have both our solutions on there. And one on either side. All right, so T is greater than or equal to -1. So what numbers are greater than or equal to -1? Well, 0. 0 is greater than -1. So my arrow is going to point in that direction. What numbers are less than -6? T is less than -6. Well, -7 is less than -6. And so we go that way. And since 1 is inclusive, we have that little line there. We have a closed-in dot. 1 is exclusive, so we have an open dot. So the OR problems, you just solve them both separately and graph them both separately. If it does say OR, they will go in opposite directions. Again, I know this isn't in your notes. Please do try it. Write it down. You've got a back page if you need more room. But write down what's in the red oval type shape there and give this one a try. I'm assuming you tried it. I'm assuming you worked at it. The correct answer is right here. If you didn't get that answer, please do watch the linked video and see how these are done. It's a little more complicated. It's like twice as complicated. You have to do them 2 times. But it is important that we can deal with things that are not always one direction. They may have to go in multiple directions, and you might have multiple answers.